It's always those simpler games that are addicting. The more complicated games, once you get a hang of it, it's like, yeah, okay, whatever. That's why I like robots versus zombies. Because those games are they definitely have an end. Okay, you finish the mission. Okay, you're done. You go back to do your homework. You study, right? With don't starve. You just do it again. It's like, okay, I survived day 10. Let's see if I can survive day 11, right? What did I miss last time? I didn't build an armor. Maybe that's why. Let's do it again. But you cannot. I think you can save the game and go from a certain point, which is good. Otherwise, you have to go start from the very beginning again, and
I don't dare start a game of StarCraft during finals week.
Yeah, you guys have to see the file name that I use for StarCraft. It's like a version number. It branches because I want to make sure that I save the alternatives also. Okay, so this time I died here, but I can restart from here or here or here or here.
StarCraft 2 is fun.
Yes, it certainly is. Which is part of the problem.
Very competitive.
All right, so what we'll do today is we are going to move on. I will go back and talk about algorithms in general later, but for the time being, I'm going to move on and talk about the variables and stuff like that. And before we do anything else, I'm going to talk about the homework assignment that you probably do not yet know, how to do it. Okay. So the homework assignment is, kind of in the format. This is kind of like a universal format for all of your homework assignment. You guys have a question? Okay. So this is kind of like a universal format, for your homework assignment. You download the file, you look at the algorithm, and then you trace it. Okay. And typically, I will give you a link to the file that you're supposed to download. And I just use, save link as, just so that, I can save the document to the folder first. And then I open it inside the browser or inside LibreOffice if you want to do it that way. And this is the algorithm that we are going to trace. It has assignment statements, which we haven't talked about. It has variables, which we haven't talked about yet. And you're going to have to trace it using the convention that I want you guys to use, which we haven't talked about yet. Okay, so there are many things that we are going to talk about today that you will need to do your homework assignment. And this is something that I usually do, with my homework assignments, is I'll give you the assignment at the beginning of a class, and then I'll go over the topics that you will need in order to do the homework assignment. So hopefully that way people will click and connect, what they need to do for homework assignment, and and kind of pay attention during the class, so that you can say, oh, okay, so this is how we do this is how we do that. All right, so I'm going to keep this one, up on the screen for the time being, and then we'll go back to topic 2, which is where we'll talk about the various topics that you need for the homework assignment. Everything that you need to know is already in this document. If you click this one, it's a link. It has a document that has everything that you need to know for the homework assignment. But I also kind of rewrote that stuff into these 3 documents down here. What is a variable, sequences, and tracing assignment statements. So you have 2 choices. Okay, you can use the first link, which is a kind of older document, but it still has the same information. Or you can choose to use the newer one, which has a kind of slightly different spin to the same topic. Okay, they are kind of equivalent. They talk about the same thing. You can choose which one you want to use. I'm going to use the new one. Okay, that's partially why it's written. Okay, so the first thing is to talk about what is a variable. Okay, we cannot write any algorithm without the use of variables. Okay. Or we can write algorithms that are pointless and utterly useless, without variables. So let's talk about what is a variable. The first thing you want to do, or the first thing you want to kind of think about when you think about a variable, is a coffee mug. Okay. Coffee mug and how much liquid is inside the coffee mug. Those are the things that you want to think about. Okay. A variable is like a coffee mug. It's a container. Okay, it can contain liquid. Okay, coffee, water, whatever you want to put into a coffee mug. So the question is, if you have a coffee mug at home, do you always have the same level of liquid in the coffee mug? Or do you think that might change, throughout a day? It probably changes, right? So in the morning, when you just wake up, your coffee mug is hopefully clean and in the cabinet, so it's empty. You make coffee, you pour coffee into the coffee mug. It's filled up to, let's say, 75%, 80% of the capacity, and then you start to drink it. You check your homework, you check the news and stuff like that. And by the time you're about to leave the house, it'll be down to here, maybe 10% or so, and so it does change over time. The coffee mug itself doesn't change, but the content changes. Okay, that's kind of like a variable. Okay, a variable is a construct in programming where a value can be stored. Now, when we talk about a value, it can be a variety type of values. Okay, for this class, at least initially, when we talk about a value, it's a numerical value, a number. Okay, that's the kind of stuff that we store in a variable at the beginning of this class. But later on, we can see that we can store other things also in a variable. Okay. So let's talk about attributes of a variable. The first thing is a variable has a name. The reason why it has a name is because in an algorithm, more likely than not, you will need more than one variables. So instead of talking about this variable, no, the other variable, no, the other variable, we just name the variables uniquely. So then we can say variable x, variable y, variable z, and so on. So when we name a variable, it has to have a unique name. You can kind of look at it as a label on your coffee mug. Okay, so let's call this coffee mug X. So now it's very easy to refer to this particular coffee mug because it has a unique name. Okay, no other coffee mug should have this name, within the algorithm, within that household or kitchen. So that's the name part. A variable has a value. Now the value of a variable is kind of like how much liquid is inside the coffee mug. It can change. The other thing you also have to know is it doesn't track the history of the value. In other words, if you ask your coffee mug, like, okay, what is the level of coffee 10 minutes ago? It doesn't know. There's no way to trace that, to backtrack and find out its previous values. The only thing you can do with a coffee mug is to take a look at it and say, okay, it's at 50% right now. Okay, so you can only see the current value, but once you overwrite, once you change the value, you cannot go back in time and say, oh, what was it before? There's no way you can go back in time. Are there any questions about these two attributes of a variable? It has a name, so we can identify one and refer to a particular one. It has a value, which is its primary job is to store a value so we can refer to the value later on in an algorithm. And the value can change. And that's why it's called a variable. It can vary. Are there any questions at this point about a variable? Okay, so let's take a look at the two things that we can do with a variable. The first thing you can do with a variable is what we call the get operation or read operation. It's basically just you walking up to a coffee mug and take a look and go, it's almost empty. Okay. In other words, you are basically checking the state of the variable at that time. In the case of a variable, you can say, okay, what is the value of this variable at this point? Okay, it's usually a number, at the beginning of this class. Any questions about the get operation, which is also a read operation? You're just referring to the value of a variable. The set operation is changing or updating the value of a variable, and that is done by a very specific kind of statement in this class. It's called an assignment statement. The general form of an assignment statement, I'm just going to load this up a little bit here. The general form of an assignment statement in this class looks like this. It has a left-hand side, LHS, a left arrow, and RHS, a right-hand side. In most actual practical programming languages, they do not use the symbol of a left arrow, and I'll explain why in this class I use a left arrow instead of the traditional symbol. This particular, the highlighted part here, is also called a meta syntax because it is a syntax to describe another syntax. So it's called a meta syntax. Okay? It's basically telling you that any assignment statements in this class has a left-hand side, a left arrow, and a right-hand side. But what goes to the left-hand side? Well, definitely not LHS. It is the name of a variable. You are naming the coffee mug that you are going to use to change. Okay, you're updating that particular variable. The right-hand side RHS is going to be replaced by an expression. The expression will give you a value, and you use that value to update the left-hand side. Are we still doing okay so far with the assignment, with the purpose and also the format of an assignment statement? So the general rule of reading, a meta syntax like this is if you see something that is italic, it is representing a token, and a token is going to be replaced in your actual program by something else. Sometimes it's just replaced by a single name. Other times it can be replaced by an expression, but it is not what it is. Okay, it's not what it seems. Okay, it's just a token. It's a placeholder so that we can refer to different parts of a statement. In this case, the arrow itself, even though we cannot see it, is actually not in italic and is also in boldface. Those are the things that you have to put into your program verbatim. Okay, so if I use a left arrow here, you're going to use a left arrow here to separate the left-hand side from the right-hand side. So that's part of the specification of a syntax. And you will see a lot of this stuff here as you move on to additional classes in computer science. And you will be learning a lot of programming languages on your own as well. Okay. Are there any questions at this point? Go ahead.
So just to kind of simplify it, LHS would become RHS?
RHS will give you a value. You use that value to update LHS. Yep. Basically what you just said. Yep.
What would we do for the arrow on liberal office? Like put the greater than.
If you use the less than symbol followed by a dash, it automatically turns it into the left arrow symbol.
Okay.
In this class, you're not going to write algorithms for the most part. I'll be the one writing the algorithms, and you'll be the one analyzing and tracing the algorithms.
Okay.
Right. And do you guys think it's important to learn how to read syntax specification?
Yeah.
Why would that be useful if computer science is in your future, or you will have to deal with programming languages?
In case you have to alter somebody's code.
So you can learn a new programming language on your own. Okay. All right. So we are pretty much done with this part here. Now we are moving on to what does it do? This is the format. This is just the syntax. But what exactly does it do? Well, an assignment statement has two distinct stages. The first stage is to evaluate the expression on the right-hand side. And then what you do is you take that value and use it to update the variable specified on the left-hand side. So the left-hand side has to be something that can store a value. It has to be something that can store a value, whereas the right-hand side is something that can provide a value, something that can give you a particular value so you can update the left-hand side. Okay. Are there any questions about these two steps that you have to perform in an assignment statement? Well, I have a question. Well, since most people read from left to right, doesn't it make more sense to have the right-hand side on the left and the left-hand side on the right so that we can just read it left to right and following the order of the operation? That makes perfect sense, right? It makes sense.
Would be nice.
But it is done this way because of a mathematical root of computer science, okay? And that's also why I do not use the symbol, which is a single equal symbol, instead of the left arrow symbol, okay? So let's move on with this document, which it will explain why I choose to use the left arrow symbol here. most programming languages do not use the left arrow symbol to represent assignment. Instead, they use a single equal symbol instead. In other words, they just say, if I want to use y to update x, this is what it looks like in most programming languages. And when I say most programming languages, I mean C, C++, Java, PHP, Perl, Visual Basic, Python. Did I miss anything important? C#, and so on, okay? There are only very few languages that do not use a single equal symbol to represent assignment. Pascal is one of those, and nobody uses Pascal anymore. Okay? But why do I deviate from the standard when every single programming language uses that symbol? Well, I want to avoid a single confusion. Go ahead.
Oh, well, I was just gonna, because most people, as you said, read from left to right. So when you showed LibreOffice, I was reading it that way and kind of didn't make much sense.
Okay.
I mean, x plus y equal x and such.
Well, we want to avoid the confusion, but the confusion comes from
Comparing two values?
yes, exactly, because we want to distinguish comparison from assignment. But aren't they about the same thing? I mean, in mathematics, surely we have seen equations like this, right? X, or most of the time it's not x equals something. Most of the time it's y equals x squared plus 2x plus 1. Okay, quadratic equation, right? Okay, we have seen a lot of this stuff in math, right? But what exactly does that mean?
Y equals the other side.
Y equals the other side. You're defining y to be, x squared plus 2x plus 1. Okay? When you talk about mathematics, what is the meaning of this statement here?
The variable x is equal to 1.
X has a value of 1. Okay? It's either that or it can be used as a condition, which is basically saying x equals 1, is it true or is it false that x equals 1? Okay? But in either case, it's not an operation to evaluate one side and use it to update the other side. In mathematics, it's a definition. In some cases, the first one is a definition. Y is x squared plus 2x plus 1. But in computer science, that's not the case. Okay, in computer science, when you look at this, if you try to write exactly the same thing here in C++, it's not the same as a math definition. It's an assignment operation, which means we evaluate the right-hand side, and then we take that result and use it to update the left-hand side. Okay. Now, the reason why it's so confusing is because the earlier computer scientists who basically determined the syntax that we are all following, they all come from a math background. And that's why they always put the variable on the left-hand side and then quote-unquote the definition on the right-hand side. So even though the meaning has changed, they still kind of use that convention. So in this class, I don't want to have any confusion. So that's why I use a left arrow symbol instead to basically make it very clear. We evaluate the right-hand side, and then we update the left-hand side. Okay. And once you are done with the update, the left-hand side and the right-hand side do not relate anymore. Okay, that's the only time you just copy the value. And that's also something. This is an example of what makes sense in a computer science class makes no sense in a math class. Because if you go to a math professor, particularly one who has no programming background whatsoever, and you ask your math professor, what does this statement mean? X equals x plus 1. What do you think your math professor will reply? How do you think your math professor will reply? It's wrong.
Yeah, it doesn't work. There is no real solutions.
Well, it depends. I mean, the math professor will give you an answer. If you demand an answer, there is an answer to this question. The answer is false. Okay, not true. Because in mathematics, this is interpreted as a comparison. And you cannot find a single value, x, such that x equals x plus 1. It just doesn't work, right? So in mathematics, it is simply false because it's a comparison and it can never be true. But in computer science, it is an entirely different thing because you evaluate the right-hand side and then you use it to update the left-hand side. So in computer science, this is really just saying, oh, you want to increment the value of variable x. If it was 0 before, now it's 1. If it's 1 before, now it's 2, and so on. But in order to avoid the confusion, I'm using the left arrow symbol and not the equal symbol. Just keep that in mind when you move from this class to the next. So here is a very simple assignment statement where the right-hand side is a constant. 0 has a value of 0. Okay, so that's the value of the right-hand side. And then the second step of the operation is to update the left-hand side, which means x ends up with a value of 0. That's it. Okay, we are resetting the value of x to 0. What happened to the value of x before this statement?
We don't know.
It's lost.
Gone.
It's gone.
We'll never know.
Yep. Well, by the time this statement is done, then we can no longer find out what the value was before the statement, because any variable can only store the current value. It doesn't have a history of the previous values. Are we doing okay so far with these concepts? Okay. And before I forget, I'm going to pass the roll sheet because sometimes not sometimes, most of the time I forget. And there we go. Thank you. Now we can change the value of a variable, but we can also refer to the value of a variable. So when a variable is appearing other than the left-hand side of an assignment statement, it is simply referring to the value of the variable at that time. Are we doing okay so far? So the referral of the value of a variable is just implicit. Whenever it's not the left-hand side of a variable, it is just referring to its value. So in this case, on line 2, we are referring to the value of x, add 1 to it, and then we use the result of the addition, the sum, to update the value of y. So that's the operation of line 2. Yep.
So that doesn't change the value of x?
No, it does not change the value of x. It is simply reading the value of x, perform the addition, and then the sum is not stored anywhere. Well, it is stored in y, but it's not stored in x. Go ahead.
So number 2 would just become x plus 1.
It is y becomes x plus 1, but because x has a value of 0, 0 plus 1 is 1, so y ends up with a value of 1. Okay. Now that's a good question, because what you're asking has to do with these two lines being a sequential arrangement. In other words, line 1 has to execute first, line 2 has to execute after line 1. Okay, it is sequential. So it's time to move on to the next document. Switch to part. Okay, let me see. How should I do it? I'm going to do it this way, just so that you guys know where to find the note 2. So it is still in topic 2. It is just the one below this document. It is titled Sequences. It's a very short one. Sequences is a really, really short document. That's it. Okay. This document is really, really short because all it wants to do is to let people know that when you read an algorithm, it is read from top to bottom. Okay. So unless you have control structures to indicate otherwise, you execute the statements one by one, line by line, from top to bottom. That's basically what this slide is saying. Okay. Any questions about this slide? It is also saying two things that are also important. One is there are certain cases where the order of execution does not matter. Okay? I can give you an example right away. So let me use mouse pad for that purpose. So I can give you one example where the order does not matter. Okay? If I have the first statement x gets a value of 1, the second statement y gets a value of 2, obviously I can switch the order of these two statements and it would not matter as the overall outcome of the algorithm. And the reason has to do with these two statements do not have any dependencies. One does not depend on the outcome of the other one. Okay. On the other hand, if I have this one being y gets x plus 1, and then x in return gets y plus 2, then it becomes kind of important how we specify the order of these operations. Okay, because I cannot really change the order much, because if I switch the order in any way, it will change the outcome. If I move this one ahead of this one here, then we have a problem, because y has no particular value by the time we get to the second line. Okay? But how do we know that y doesn't have any particular value by the time we get to the second line?
Because that's specified.
It's not specified. So, but you can do this. We can currently do this just by tracking the state of all the variables in our minds, as we go through this particular pseudocode line by line. But when our algorithm gets more and more complicated, not only do you have to keep track of which line you're executing, you also have to keep track of the value of all the variables at that particular moment, and that can be tedious. Okay, so why do we have to spend our brain juice, on something that can be done by computers and documents and and software tools? So that's why we have another slide that will basically talk about how to trace an algorithm. But before we move on, let me just make sure that we cover all the important points here. A sequence is a list of statements from top to bottom. The implicit order is just the same way that we read in English. Okay, because I know different languages may read in different directions, but in English we read on the same line from left to right and then from top to bottom. So we read algorithms the same way. Why do we borrow so much stuff in programming from English? Has to do with the historical, has to do with the history of computer science. Go ahead. Yep. The first computer scientist is Alan Turing, and Alan Turing is a British. He, at the end of World War II, he was the one who helped design and build the Colossus computers for decrypting German transmission. And he is considered, and rightfully so, the father of computer science, because the stuff, the theories that he came up with, is still the kind of stuff that we study today in 4-year university. You probably won't be studying like state machines and computation theories here at AR, but when you move on to a 4-year university along your computer science track, you will be taking those classes. And Alan Turing stuff will still be the same stuff that we are studying today, and it's still valid too. It's not like ancient, archaic stuff just for historical purposes. So make sure that you observe the order of statements in the sequence. So now we move on to the last one. The last one is basically convention. Tracing assignment statements is all about conventions of tracing algorithms in this class. So I'm using this particular example here. It's defining, this document defines how we trace assignment statements, and also basically the starting point of how to trace something. What I call a trace is basically a table, and we can divide a table by different means. One way to divide a table is to look at it on a row by row basis. So when you look at a trace on a row by row basis, each row is representing a slice of time. Okay. In other words, a trace is kind of like having a video camera looking at the values of all the variables as the algorithm executes. So just kind of imagine that you have this really fancy screen that has the value of every variable displayed on the screen, and your algorithm is executing at the same time. You have a camcorder pointing to the screen, and it's recording how these values are changing as the algorithm executes, and that's a trace. When you look at that trace, and when you look at a table, if you look at each horizontal row of a table, it is representing a frame of the video recording. It is just freezing time, and you can say, at this particular moment, what are the values of these variables, and you can tell exactly what they are. Okay? A column, on the other hand, if you look at a column in a trace, it is representing something that we want to track over time. It's representing the history of that one something that we want to track over time. Now, even though the variable itself cannot remember its own old value, this is an external tool. This is a tool that is external to the variable that we can use to do the recording. Okay? So it has nothing to do with the variables themselves. This is an external observation tool to do that. Are there any questions about this part? Questions? Okay. A trace should have the following columns. At this point, later on there will be more types of columns. The first column, the leftmost column, is the line number column. In other words, when we create a trace, we want to say, and after this line in the algorithm executes, that's the result in all the variables. That's why we have a column just to represent line numbers. And then on top of that, onto the right-hand side of the line number column, we'll have one column for each variable referred to in the algorithm. In this case, we'll have 3 columns because we have one column for the line number, one column to track the value of x, and one column to track the value of y. And as a result, this is kind of like the general format of the trace for this particular algorithm. When we trace it, okay, let me just go back here, go to here. I'm not reading my notes line by line, just because it's boring, but I can just point out what I need to go through here. After the first row of your trace is just the labeling of each column. So we have line number as a label for the first column. We have x and y as labels for the other 2 columns, because one is representing the values of x and one is representing the values of y throughout the execution of the algorithm. The second row starts with a word pre. Well, if you look at the algorithm, there's no such line as pre. So pre has a significance because it is stating the precondition of the algorithm. In other words, it's stating what assumptions can we make prior to the execution of the algorithm. Now that can be important. In this case, it doesn't seem very important because all I'm saying here with question marks is to say, I don't know the value of x, I don't know the value of y before this algorithm starts execution. But that's an important assumption because in C++ and many other languages, when you use global variables, the initial values are not determined. Okay? It sounds very simple, right? You just cannot assume a particular value when you start to use a variable. But someone, somewhere along the line, is going to forget that. Now, I know that because I have forgotten that many times already. That's not the bad part. Okay? There are 2 really bad parts to this story. One is the compiler, unless you turn on super nagging mode of the compiler, it won't tell you. Even though it's something that's really suspicious, most compilers would just go, I think you know what you're doing. No problem. You can refer to a variable that is not initialized. Okay? That's the first problem, is the tool does not automatically do it. You can make it do it by turning on the super nagging mode, okay? And you will learn how to do that in your next class, okay? If your professor in cisp300 does not say anything about that in the first class, the first time you guys are introduced to the programming environment, remind your professors to do so, okay? How do I turn on the super nagging mode of the compiler? Because that will save you a lot of time, okay? So let's say you turn that on and you can catch these things, right? If you don't turn it on, you cannot catch these things. And sometimes your program will still work correctly. Because under certain circumstances, in certain types of environments, the debugger of an environment, of an IDE, will quote unquote automatically initialize global variables to zeros. It's just one of the things that they do, okay? With a debugger, it will do that. So when you're debugging your program line by line using an IDE, an integrated development environment, your program seems to work fine because they all start with quote unquote known beginning values, which usually are zeros. So here comes the time to compile the program into an executable. You give the professor the executable to test it, right? Well, without a debugger, there's no one to initialize those variables to zeros. So suddenly, the program that has been working all along when you are using the debugger to debug the program suddenly doesn't work anymore. That's a tougher problem because when you're testing the program, it works, but when you turn it in and the professor runs it, not within the context of a debugger, suddenly it doesn't work anymore. And that has to do with the assumption of the variables getting initialized when they are not. Okay? So that's why in this class, if someone turns in a homework assignment as a trace and forget to tell me that certain variables are uninitialized, points will be taken off. Okay? Not because I'm picky, but because I need you guys to understand that is important. Okay? All right, so after pre, which is the precondition of the entire algorithm, we start with line 1 in this case. So when you look at this cell here and also this cell here, they represent the result after line 1 executes. In other words, the row 3 of this trace is saying after line 1 executes, x ends up with a value of 2, and y still has an unknown value. That's basically what it's saying. And the next row talks about line 2 is the result of after executing line 2. So in this case, it's saying after line 2 executes, x still has a value of 2 because line 2 only affects y, it's not x. And y ends up with a value of 3. And that's the end of the entire algorithm. I use a word post here in the line number column to indicate this is the end of the entire trace. It's kind of like QED in the math class. It tells the math professor that you're done with the proof. So this is basically serving the same purpose. You're telling me that this entire trace is done at this point. Post stands for post condition, by the way. Are there any questions about the convention of a trace in this class? Because you will have to observe these conventions also when you turn in your homework assignment. So without any questions, let's go ahead and start an example so I can do something to illustrate how to get your homework assignment done. So I'm going to close a few documents. In fact, I'm going to close them all and then reopen just for this example. So exit the whole thing. Open the document. And by the way, I am done grading the first homework assignment. Of the people who turn it in, I would say 90% at least, got it done perfectly fine. Okay, I can see the author name, okay, your name as the author of the document. I can see the log, okay, I can see how the document got changed. And I can see your name, your student ID, everything works out just fine. A few people turn in files that I cannot read, so those I cannot give any points for those. And I think a few people forgot to set the name, maybe one or two. When I said a few, it's not really too many. So when you check your grade book in Moodle, you should see your grade for this homework assignment. It's done as of last night. Right. So I'm going to give myself, an algorithm to trace. So let's go ahead and start with x gets a value of, say, 20. Y gets x minus 5. And we'll do another one. X gets y minus 5. And then we'll have x to get, x plus 2. Okay. So this is my entire algorithm. And by the way, an algorithm is really just a method or a specification of operations in, as instructions to a computer. So now I want to trace this algorithm. Okay, it's not really complicated. It's just we have to do it step by step. I typically would use another sheet in the spreadsheet document for the trace. So if I press this little plus symbol here down there, it gives me a new sheet that I can use for my trace. So as we talked about a little bit earlier, I need the first column to represent line numbers, and then I need two columns to represent the values of the variables. In this case, I have a variable x, I have a variable y, so now we have 3 columns. And these columns are taking up more space than they really should. So what I can do is I can select the columns. If you want to select an entire column, you click the heading of the entire column, like A, B, and C here, and you can press the Control key as you click the columns, so that will allow you to select multiple columns at the same time. Now, when you have selected multiple columns, or even just one, if you go to the border between 2 columns, your cursor will turn into this double-sided arrow thing, and at that time, if you double-click it, it will automatically resize the columns to just as wide as they need to be, which is really handy, because you don't have to resize each column independently. And all of this stuff is still getting recorded, so you can actually replay this when you need to. Let me just double check. It is recording. Sometimes the recorder stops halfway through the class for one reason or another. I have hard drive failures before where the whole thing would just crash and not stop recording. Right. So let's go ahead and start the tracing of our algorithm. Now, since I don't need to make any assumptions, so the precondition is we'll just say that we don't know the value of x nor the value of y to begin with. Now we have to revert back to sheet 1 to find out what line 1 is going to do, go back to sheet 2 to update it. That seems really tedious, right? Having to switch between 2 sheets back and forth all the time. Fortunately, LibreOffice and also Microsoft Office has this feature too, but you cannot use Microsoft Office for this class. But LibreOffice has this feature called Window. If you go to the Window menu and you click New Window, it will give you another view of the same document. In other words, I'm looking at exactly the same document. It's the same document called Untitled 1, but these are 2 different views at the same time. They're concurrent views of the same document. I have one fixed to, okay, usually the way I do it is the one on the left-hand side is looking at the algorithm, and then the one on the right-hand side will be looking at the trace. So this way you can look at the trace and the algorithm at the same time, so you don't have to go back and forth all the time. Do we have any questions? So when you do your homework, you have to use sheet 2 for the trace. You cannot just say, I'm going to do it on the side of the algorithm. You kind of have to follow this convention. All right, so let's go ahead and take a look at line 1. So now we want to answer those questions. The question is, what is the value of x after line 1 executes? 20. Very good. Okay, so that's 20. And 20 is too wide to fit in the space. You can just double click it again to let it automatically resize the width. What about y? It's still a question mark because it's not changed from before, so it's still a question mark. What about after line 2? What is the value of x after line 2?
Doesn't change.
It doesn't change, exactly, because x is not on the left-hand side, so we know line 2 is not changing the value of x. It still has a value of 20. It retains the value of 20. What about the value of y?
15.
It's 15, okay? But why is it 15? Well, line 2 is an assignment statement, which means it has a left-hand side and a right-hand side. Step 1 of an assignment statement is to evaluate the right-hand side. The right-hand side is x minus 5, and x has a value of what at this point? 20. 20 minus 5 is 15. So the entire right-hand side evaluates to 15. And what do we do with 15? We use it to update the left-hand side. Okay? So the left-hand side, which is y, is now updated to a value of 15. And once again, 15 is too wide. We just have to resize the column a little bit. Now we move on to line 3. Line 3 doesn't seem to do anything to x, right? So x gets to keep its value, which is 20. But then the y portion looks kind of confusing now because the left-hand side and the right-hand side, they both contain y. So it seems to be kind of like a cyclic kind of reasoning, but it's not. Okay, because an assignment statement has distinctly just 2 steps. Go ahead.
When you're incrementing down by 5.
You're decrementing by 5. Okay, you're exactly. Okay, because you still have to follow those exact 2 steps. What is step 1 again? Evaluate
The right hand side.
Okay, very good. So at this point, okay, when you look at the trace, at this point, what is the value of y by the time we start to execute line 3? Y has a value of 15. Okay, so when we look at y minus 5, it's 15 minus 5. Does it make sense?
Yeah.
15 minus 5 has a definite answer. It's 10. Okay, so the entire right hand side evaluates to a value of 10. What do we do with that value of 10?
Assign it to y.
We update y with it, so y ends up with the value of 10. And we are done, okay? We don't ruminate and say, oh, y is getting its value changed, so we have to go back and re-evaluate the right-hand side. No, we evaluate the right-hand side once. We update the left-hand side once. We are done, we move on. All right? Okay. Yep.
Would it be wrong if you were to put x minus 5 for 15 first and then update it later?
Say again?
For row 4.
For row 4?
If you put x minus 5 instead of 15, and then for line 5, you put 20. And
No, these have to be specific values. When you look at the trace, each cell has to be a specific value.
Switch those.
Yeah, they cannot be how this value relates to somebody else's. It has to be a particular value.
it cannot be any equation.
Cannot be equation. Yep. That's a good question. Cannot be equation. Yep.
But the order of 3 and 4 wouldn't matter, right? Because they're not really relying on each other.
That is correct. In this case, the ordering of, I can switch the order of lines 3 and 4 in the algorithm, and that would not affect the overall outcome of the algorithm. Correct. So now we are moving on to line 4. Line 4 is an assignment statement. We evaluate the right-hand side first. The right-hand side is x plus 2. X currently has a value of 20. 20 plus 20, excuse me, 20 plus 2 is 22. So the entire right-hand side specifies a value of 22. We take that 22, we use it to update the left-hand side, which is naming variable x as the one to be updated. So we update column B, which is representing variable x. So it has a value of 22. What about y?
15 or 10.
It
Why
keeps
does
its
it
value of
change?
10, right? Because it's not affected. And we are all done at this point. We say post to indicate the end of the entire trace. Yep, go ahead.
How did you get line 3 again?
On line 3?
Y minus 5. Y equals y minus 5.
Y
How did you
gets
get
y minus 5.
20 for x. X just keeps its original value.
Correct. Remember,
Except
this is
15 minus 5.
yeah. The trace is a video recording of how the values of the variables got changed. When you look at it horizontally, each row is a frame of the video. So in order to determine a new frame, you have to look at the previous frame and say, okay, this variable has a value up to this point, and we're going to use that to do the calculation to update something. Yep.
So you basically look at the frame before, you don't look back at the history before that or anything, the original?
Because it can only store one value at a time. It's just like a coffee mug cannot contain 2 different levels of liquids at the same time. I know you guys are smart. You can say, well, but I can put like 1/3 of oil in it and the other half with water, right? Yeah, I know you guys are smart. But you can, but there's
Of the
still,
same type
but
of
the
liquid.
level is still the same. There are 2 different types of liquid, but the top of the liquid is still, there's only one level overall. Even though half of it is oil. Okay, so do we have any questions about the homework assignment? Does everybody know how to do the homework assignment? Okay, so you still have to observe the same thing as last time. You have to download the documents from Moodle first, and then edit that document. Okay, do not do any type of copy and pasting. Make sure that your name reflects as the author of the document, and make sure that you do it in LibreOffice. or open office. Yes?
So we're just doing the tracing?
Hmm?
We're just doing the tracing?
Yep.
Okay.
With the homework assignment, you have 1 week to do it. Yep.
Just an idea. Maybe like take this file, the one you currently did, and add it as an optional download, so for people who can have that as a reference in the format.
I want you guys to do it yourselves, so that you can actually reproduce the steps too. That gives you a chance to actually, learn how to use LibreOffice too. It's simple enough, by the time we get to a trace that are like 30, 40 lines, then I'll consider uploading it. Okay, so any other questions about the 3 main concepts that we have gone over at this point? Yep, go ahead.
For column 2, will you always put pre into question marks, or if you already know what variable is?
Occasionally, I will give you a trace where I will give you assumptions of values. So the pre-row will have specific values for certain variables. But in general, in most cases, no. In most cases, they will be unknown, and they should be represented by question marks. All right. So there are 3 main concepts that we have talked about up to this point. First one is the concept of a variable. Okay, a thing, an object, a construct in programming languages to store values, and you can have many of those things to store different types of values too. Second thing, assignment statements. Okay, that's the only mechanism up to this point to change the value of a variable. Third thing, a sequence. Okay, the concept of a sequence, which means we read programs or algorithms from top to bottom, and you have to follow the order of execution as specified in the program. Okay, you cannot just say, I like this line better because it's easier, I'll do it first. Okay, you have to follow the order as specified. Yep.
Question about Moodle. Where would we go to check the grades?
You go to your gradebook.
Okay.
Under administration, on the left-hand side, there's a tab, not a tab, but a little box that says, administration. Under that, I think you guys should only see grades, so that will be your gradebook.
Okay.
It will look super duper confusing at this point, because a lot of those items apply to the previous exam 1, exam 2, and the final exam, so I have to kind of clean it up too. But the assignment that is already graded, you should be able to see your grade over there.
Okay.
All right. So let's move on. Or is there anything to move on to? I mean, isn't that all we need when we write algorithms?
Yeah.
Variables, assignment statements, and sequences. What else do we need? I mean, I think we can move on and talk about writing apps now. Logic. Okay, why do we need logic in a program?
That way it works.
Okay, tell me an example of logic. We can do computations now. We can store values now, right? Okay, but it doesn't get us very far. Why doesn't this get us very far with just the ability to store values and do assignments? We can certainly do complicated calculations already. Okay, you can write an algorithm that can solve quadratic equations now. Okay, what about finding the maximum of 2 variables? I give you variable x, I give you variable y. I want you to write an algorithm to find the maximum of those 2 and store the maximum in a 3rd variable. Okay, well, let's take a look at that example. I give you variable x, I give you variable y, and I want you to store the maximum in variable z. Okay. Well, since I just said, store, right? That should immediately prompt you and say, oh, we need assignment statements, because that's the one mechanism that you can use to store a value into something else. So that means, okay, we know this something is going to be in the algorithm itself. Does it make sense? Okay. Well, the maximum of 2 variables, sometimes it can be x, and other times it can be y. Now the question is, which one should I use? Okay, what would be your answer? What is your thinking process right now? We know that sometimes we need z to get the value from x. Other times we need z to get the value of y, because they... Go ahead.
X plus y? Since you're trying to get the maximum value of them both, wouldn't it be best to add them both when they're at their highest?
No, but when you add them both, it's not either of them anymore unless one is 0. Yep, go ahead.
You use if and else statements.
Okay, and that's because, okay, we know that we have to use one or the other operation. And okay, what is the word that I should use to connect these two statements? Else. What about choose? Okay, I need to choose. At some point, I need to choose which statement I want to execute. And there's another statement that is also important, another word that's also important, depending on
Which one's greater?
Which has a higher value.
which has a higher value. Okay, very good. So all of those are keywords. Okay, store is a keyword because it tells me we need to use assignment statements. Choose is a keyword because it tells me I need a conditional statement. Depending on blah, 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 tells me what condition I need to use in the conditional statement. Okay, so all of those things, when we say it out loud and say that, well, we cannot do it like this because we cannot do both statements. We have to choose one or the other. Right away, choosing means conditional statements. But how do you choose? Well, I have to choose one or the other one depending on which one is larger. Well, depending on tells you, the condition of the conditional statement. So all those things are important. All right, so let's take a look at this problem here, and we'll imagine that we are in a nature hike. Okay, this is a nature hike, but arranged for computer science students. Okay, so as you are walking, on the trail, you'll be doing certain things. Okay, you'll be doing assignment statements and other things too. Okay, so here comes a trail. It's in computer science, all trails are one way. Okay, it's kind of like streets in San Francisco, they're one way. Confusingly one way. Okay, so it's a one-way street, and we know that in order to find the maximum of two variables and store the maximum in a variable z, we sometimes want to do this. Okay, sometimes we want to say z gets the value of x. Other times we want to say z gets the value of y. Right? So that means this trail cannot be just a straight line. It cannot be a sequence. It's not a straight line. Okay, it has to branch. Okay, it has to branch. In other words, it has to go this way sometimes, and it has to have another path to lead to this way here. Okay. But these two branches will eventually merge. Okay, because when we are done with determining which one is larger and get our maximum, then we are done with this particular code, and then we can merge the two paths and exit. Okay, is that making any sense so far? Sometimes we need to do this, sometimes we need to do that, but which way should we go? How should I choose? Well, depending on the relationship of x and y, right? So that tells me that in order to choose which way to go, there has to be a sign here alongside of the trail grass with a question. Okay, this is not a statement. It is not a statement saying that x is larger than y. It is a question. Is x is greater than y true or false? It is a question. So in other words, you really should put a question mark here because it is really a question. Okay, is it true or is it false? Well, depending on what I give you as a value for the x and the value of y, sometimes it's true and sometimes it's false. So now we have to label the paths as well, because this path here should be labeled true because that's the way you choose. When the expression is true, you go this way. When the expression is false, you go the other way. And guess what? We have our conditional statement. Are there any questions about this conditional statement here? Represented as a trail map. Okay, well, at this point, something just crossed my mind, but I have to share that because it's kind of related to this class. but it might has the potential of taking me to a really big long digression too. In the Bay Area, right now, writing apps is a big thing. Okay, there are companies that will start up quote unquote academies to teach people how to write apps, mobile applications for iOS and for Android. And some of those academies would charge $12,000 for a 8-week class. That's a lot of money. Okay, this class is a full semester class, so it's a 16-week class. And I don't know how much you guys pay for your units, but I would imagine it's a small fraction of $12,000. Okay, I'm just thinking, around here, an academy like that can go to REI so that they can take programmers onto hiking trails, but along the hiking trail they have road signs like this before a fork, a branch, so that people can actually trace an algorithm by hiking, which is good because we programmers tend to kind of stay too much on the chair and not get out enough, right? So turning this into an actual trail would be kind of not a bad thing.
Well, depends on who you ask.
Depends on
what you mean by bad.
Yep. But anyway, getting back to this one here. So is the logic clear, what this picture is representing? The logic of finding the maximum of 2 variables and storing that into a third variable. Is that good? Okay. So now we have some additional questions. It's nice to have a pictorial representation of an algorithm. And I can even do pictorial programming. Okay. With this class, I'm moving a little bit faster than the other class, so I can show you this too. My son was just here the other day, like last night. It's scratch.mit.edu. It's really cool because of all the concepts that we learn in this class is all about tracing by hand, okay? Some people don't like it because it's very tedious, very dry, very boring, okay? So if you want to apply what you learn in this class to something that's kind of fun, something that you can actually get hands-on experience and say, well, I want to make it work. I want to see my algorithm work and not just tracing it. This is a good place to go. So I have an account already set up here. So let me log in my account. And in a way, it's kind of like YouTube. It's community-based, which means once you write a program using Scratch, you can release it so that other people can play with it. And not only can they play with it, they can see your source code as well. And the licensing of your projects on Scratch is all GPL, General Public License. GNU Public License, which means it's open sourced, so other people can take your project and modify it. Okay, on this site it's called remixing. Okay, so other people can take your project and remix it. My son is remixing some people's games and actually finishing some unfinished games by himself. So it's really a lot of fun because some people have a great idea to start with, but somehow they ran out of steam and couldn't quite finish it. So if you see a halfway finished project, you can go ahead and finish it, and it's perfectly okay with this. So what I'm going to do is I will create a new project to represent the logic that we are talking about here. All right. And this is all web-based. You don't have to install anything other than a browser. And it works with most major browsers. It's kind of slow. Okay, so now we have Scratch the sprite, and we're going to use a small, tiny fraction of what this particular environment can do. So what we'll do is we're going to have the 3 variables. Okay, so to create variables, we go to Data, and then we just say make a variable. At this point, whether it's for all sprites or for this sprite only, doesn't really matter. So we just say X is a variable, Y is a variable, and Z is a variable. Did you guys see what I just did? I just click make a variable 3 times, and then each time I just have to name the variables. So we have X, Y, Z as the 3 variables that we have here. And then I can go back to the code here. This area here is where your program goes. So I want to specify my program now. To start my program, I go to control, and maybe not control. Let's see. Events. They moved it. I will use this symbol here. When the green flag is clicked, which is this little green flag here, it starts the execution of the whole program. It's just a trigger to start the entire program. And then what I'll do is I'm going to go to, I think, looks here, maybe not. Sensing. They put it into sensing. So I'm going to have the cat to ask me a question. So I'm going to change this question here is, what is the value of x? And then I will take the input, which is in the form of a tiny little text box, and I'll take that and say, set the value of x. I know some of you cannot read it because it's really small font here. Set x to, instead of using a particular value, I'll just say the answer. Okay? When we talk about the answer, it is the answer to the question that was just asked. Okay, so this is one easy way for Scratch to interact with a user. You can type something and you can take your input and put it into a variable like this. Okay, so I'm going to do this twice. Excuse me. So we'll do this. Oh no, I don't want to run it yet. Okay, so I can duplicate this block here and do it this time is for y. So let me change the text here. What is y? And wait. Put this block back here. All right. So with these blocks here, the program would start when I click the green flag. It will ask what is the value of x. It will ask what is the value of y. Okay. And then here comes the really cool part is I'm going to write this code here in Scratch. Okay. We have already identified this is a conditional statement. We want to use a condition to determine which way to go. If we go this way, we got these things to do. If we go the other way, we got the other stuff to do. Okay. So we go to control here, and under here we have if then else. Okay, that's basically a conditional statement. If then else. This block here, if you cannot see it, is in a hexagon type of shape, which means it has to be a Boolean expression. It has to be something that can return true or false. So what we need to do is to do a comparison under operators. So here we have the greater than operation or the greater than operator. We drag and drop it into here. We are comparing x and y. We'll follow the code exactly the same as on the whiteboard. So we go back to data and we drag x to the left hand side. We drag y to the left hand side. Right. Yeah, to the y to the right hand side, x to the left hand side. Okay. So depending on the comparison, the outcome of the comparison, this block here corresponds to when the condition is true. This block corresponds to when the condition is false. So we will use set z to something here and also the other one. But we don't want to set z to 0, which is the default. We want to set z to x in this one. We want to set z to y in the other one. And there's our conditional statement. But right now the program doesn't do a whole lot except to do the computation. If you want the cat to reply to you and actually tell you the value of z, it will be reflected here anyway, okay? But if you wanted to actually reply to you, you can go to looks again, and then you can say, you can use the say operation here. But instead of say hello, you can use variable z to specify what it wants to print out or what it wants to present. And that's the end of the program. You go to control again, and there's one block to end the execution of everything, stop all. And we have our algorithm specified as a Scratch program. So let's go ahead and run it and see what happens. Okay. Yep, go ahead.
I was gonna. Shouldn't you do say something for X amount of time? Otherwise, it'll just stop immediately.
I don't remember. Let's.
I think it does.
Yeah. So the first thing is it asks me for the value of x. It has to be a number because otherwise the comparison won't work. So let's try 23 here, and then y we'll try 14. So the maximum should be 23, and yeah, the say doesn't last. But you can also see here z has a value of 23. So it does get the right thing done. It's just that the say part has no delay, and the program stops right away, and so the dialog box just disappeared. Okay. But this is really just the tip of the iceberg of what you can do with Scratch. Scratch can do a lot more than this. Some people write games, using Scratch. It's kind of like an interesting thing for those of you who just feel that tracing algorithms is too dry, too boring. It's a fun thing to do. If you want to see what other people are doing with Scratch, you can just go back to the main page here. They have Super Mushroom Bowl. Click it, run it. Oh no, my computer is hacked.
That looks like so much like this Shy Guys.
So what does the code look like for that?
If you want to look at the code, you can click See Inside, and that's the code. So this is, each sprite has its own code, so you can see that if you click on each sprite, this one has no code, but if you look at this sprite here, it has some code here. It's supposed to have sounds too, so I can.
Do they do anything, or do they just do that?
I think this one doesn't do anything, but there are quite complicated games too. So if you, they rank these things by popularity too. Village Builder, Dodge this.
Physics simulations.
Where?
Top left. Yeah.
And it's a great way to learn programming too, because sometimes you see something really cool and you go, wow, how did they do that? And then you can look at the source code. You can learn exactly how to get it done. Magnetic and needle. Okay, let's try that. Okay, instructions: move the magnet or needle with mouse. Click on needle to draw a magnetic line. Use arrow keys to turn the magnet.
Right. You have to, yeah.
Ooh. Okay, click on needle to draw a magnetic line. Okay, click. Ooh. Click it again. Oh, this one's going to outer space. Repulsion, right? Well, no, the pole should go in there too. Oh, there you go. It's flying back. It's coming back. But I think the calculation is actually based on magnetic flux calculations. So it looks simple. It looks kind of childish, but it's really not. And you can enable the sound. For some reason my sound is not playing.
I'm wondering why there's sound on this in the first place. So
It's
like
supposed to
content.
have sounds. I mean, let me see. Playback. There you go. Yep. Well, that's the app. I mean, and then you can look at the code. You can go to see inside, and that's the program. That's the code. Okay, and just about anyone can start programming on day one because there's no syntax to learn. Okay, you cannot drag and drop something to some place that it does not belong. That's the key. Okay, so that's the syntax right there. The shapes have to match. Okay, if it doesn't match, it doesn't drop in, and so you don't get syntax errors whatsoever. It just doesn't drop, doesn't connect. So I strongly recommend people to take a look at this, because it's really just fun, in some cases, and it's also very educational too. My son is 9 years old, okay, and he is modifying scripts, just by reading what other people have done, and he's learning by reading that stuff and experimenting with new scripts. And you don't get the frustration of running into compiler errors and stuff like that you typically would deal with, have to deal with when you're programming in C++ and whatnot. So it's really quite interesting. Well, for those of you who, once you're done with Scratch, and you say, well, that's kind of like a neat toy, but I don't really want to play with toys anymore, you can play with this. It's App Inventor. App Inventor has a programming interface that's similar to Scratch because it's also done by the MIT Media Lab. But this one can write apps that will actually run on Androids. So you can actually finish apps using App Inventor and put it onto the Play Store. If you want to pay $25 to register, you can actually own your own Play Store account and then push your app that you have written in App Inventor and have your app published that way. I would think that maybe before the end of this semester, somebody's gonna do it in this class. It's gonna since I know enough about programming, I'm gonna give myself some assignments. Yep.
I don't think you can use a gift card to register.
Say again?
Do you know if you can use a gift card to register? On the
Can you
Play
use
Store?
a gift card to
I've got
register?
Play gift card.
I would assume so because it's just using your Google account to pay for it. If you pay $25 to register, you can publish apps, but you cannot publish paid apps. So in order to establish a paid app, you have to have an account to receive money as well. And then Google wants to share, so you have to read the full agreement stuff if you want to do it that way. But if you just want to share your app, and distribute it, $25 is all you need. And it's not like Apple where you have to pay I think $100 a year. This $25 is like you pay $25, you're done. I mean, you can do.
Come back 30 years later if they're still running it.
Yep.
You got it.
Exactly. All right. So we're running out of time. I'll see you guys on Thursday. Continue to read the conditional statement stuff, because that's what we're going to talk about on Thursday.